Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, you should have a hunch that this will be a lot bigger than this as n heads towards infinity. Because if I were to give you n over natural log of n, so y equals x looks like this, y equals natural log of x looks like this. So when you start out with n and then you put it into here, then you can see that this thing here will be a lot bigger than this thing here as n heads towards infinity. Now, when you have natural log of n over natural log of the natural log of n, then you start out with n, you put this thing into here, and then you put the whole thing here into here. Then this natural log of the natural log here will be a lot smaller than this natural log here. The point is that by looking at this, you should have a hunch that this will be a lot bigger than this as n heads towards infinity. Meaning your sequence will do something like this. It will get bigger and bigger and bigger. So you should have a hunch that it might. Looking at this, you should have a hunch that it might not tend to zero. It might not tend to zero because if the denominator gets bigger and bigger, if the denominator gets a lot bigger than the numerator, then you can tell that it's heading towards zero. But here you've got the numerator that seems to be getting bigger than the denominator. So you have a hunch. You should have a hunch that it might actually get the sequence itself might get bigger and bigger and bigger. So you should use the nth term test, meaning you should look at the limit. You should take the limit as n tends to infinity, of natural log of n over natural log of n. You should take the limit as n tends to infinity, because in order for any series to converge, the limit of this thing must equal zero. It must head towards zero. It cannot get bigger and bigger and bigger. It must head towards zero. So looking at this, you should have a hunch that, well, looking at this, use the nth term test. So using the nth term test, we need to make sure that the limit of this, we need to make sure the limit equals zero. We need to make sure that the sequence itself heads towards zero. We need to make sure that. So as n tends to infinity, natural log, this thing here will head towards infinity, and then this thing here will head towards infinity. When you put into the natural log again, the whole thing here will also head towards infinity. But we have a hunch that this will climb a lot faster than this. But at the moment, as things stand, it's infinity over infinity, which means we can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate this, that will then give you this. Differentiate this, that will then give you this. Tidy this up, that will then give you this. So the two ends will cancel each other out, leaving you with this. So as n heads towards infinity, natural log of n will just get bigger and bigger and bigger. It's going to head towards infinity. So you've got a sequence that keeps on getting bigger and bigger and bigger. Therefore, you know that the original thing will diverge, because in order for any series to converge, the limit must be zero. But here we've got a limit that keeps on getting bigger and big. Well, we've got a sequence that keeps on getting bigger and bigger and bigger. Therefore, we can conclude that this will diverge. Okay.